Hello everyone, I'm Rishabh. In this video, we are going to build a Selenium automation framework from scratch, the way it's done in real projects. Most Selenium tutorials teach you how to write tests, but they never teach you how real frameworks are designed. In this video, you will learn why every folder exists, why every class is written the way it is, and how to design for parallel execution and stability. If you're tired of flaky tests, messy code, and frameworks that collapse as they grow, this video will change how you think about Selenium automation. Let's get started. We will start our framework creation by first setting up IntelliJ and Git. I am assuming that you already have Java installed on your system because Selenium with Java requires the JDK. If you do not have JDK, IntelliJ itself gives you an option to download and configure the JDK while creating the project. So you don't need to worry about it separately. We can install IntelliJ and Git from their official website by downloading the installer files or by using the commands mentioned over there. So once Git is installed, we can check the version in command prompt or terminal using the command git hyphen hyphen version. Okay, let's set up the project now. It is a Maven based project and I will put the project name as Selenium Framework. I already checked the create git repository, so it will initialize the git repo by itself. Also, it will show the JDK which will be used while creating the project. Let's hit create. Once the project is created, IntelliJ gives us the default Maven structure, which includes src main Java, resources, src test Java. Instead of making this a very long video, I will explain every concept as we build the framework together. The important thing to understand here is the separation of framework code and the test code. All framework level code will go inside the src main Java, which includes everything that support test execution, such as configuration management, driver management, utilities, and page objects. On the other hand, src test Java is strictly for the test logic. This separation is extremely important for scalability. If we mix the framework logic and the test logic, the framework becomes hard to maintain as the project grows. Inside the src main Java, we have created 4 packages: configs, drivers, pages, and utils. Inside the src test Java, we are creating 3 more packages like hooks, step definitions, and runners. This structure already reflects a clean structure. The config package will handle configuration management. The drivers package will be responsible for browser's lifecycle. The pages package will contain page objects that represent application behavior. The utils package will contain reusable helper logic that does not belong to any specific page. In the test layer, hooks will manage the test lifecycle events. Step definitions will map feature steps to automation code, and runners will control the execution. Let's start with the configs package and create a first class ConfigManager. The responsibility of ConfigManager is centralized configuration access. Any class in the framework that needs a configuration value should never read files directly. Instead, they should ask ConfigManager for the value. This enforces consistency and keeps configuration logic in one place. Now here, we are making this class final because it is not supposed to be extended. This class is only responsible for reading configuration, and that behavior should stay same everywhere in the framework. So making this final removes the possibility of inheritance here, which will avoid confusion and unexpected behavior later. Inside config manager, we create 2 class level variables and make them private and static. They are private because we never want any other class to change the environment values or properties directly. If configuration values change during execution, tests behave differently every time, which makes debugging very difficult. They are static because we want configuration to be loaded only once and shared across the framework. This also makes it memory efficient and safe to use across multiple threads when we are only reading values. We load the environment and properties inside a static block. A static block runs automatically when the class is loaded, so it guarantees that environment and properties are ready before any test or page tries to access them. So we now know the importance of 2 major keywords used in the framework creation: final and static. Final, we created this class as final as we do not want any child class to modify its behavior. Static variables to make sure that these variables are shared across the framework. For handling the environments, we create an enum called environment. Its job is to define all allowed environments in one place. Instead of passing environment names as a plain strings, we restrict the framework to accept only valid values. This avoids spelling mistakes, invalid environment names, and silent issues that are very hard to debug. Okay, so let me update the string variable to environment enum. Now we are going to implement load environment and load properties method. Both the methods are private and static. Now we need to understand one thing. Even though load environment and load properties are private, the data they are going to prepare is global. This static block, which is mentioned above, runs automatically when the ConfigManager class is loaded by the JVM. At that moment, the private method loads the environment and properties and store them in the static variables. Now let us get the environment value which is used to load the environment, right? We are going to use system.get property, which is basically a way for Java to read values that are passed from outside the code, usually from the command line or from a CI tool. The first value env is the name of the property we are looking for. The second value qa is the default value, right? Which it means that if someone has passed an environment value called env, then pick that value and store it in env value. But if nothing is passed, don't fail, just use QA by default, right? For example, if we run the project like mv and test -d env equal to UAT, then it will set the property as UAT and it will run in the UAT environment. Now this line validates whether the environment value provided is correct or not. We get the environment value above in the above line, right? Then we convert that value to a string and we try to validate it from the enums. If the value is present in enum, then it is a valid environment. Otherwise, we catch that exception into the catch block, right? And we will exit by throwing an exception saying that the environment value is invalid. Let us now implement the load properties method. So in it, we need to define path from which the properties will be loaded specific to the environment. For example, QA environment will have separate properties. The UAT environment will have separate UAT properties, right? In it, for all these, maybe the base URL is different. Maybe some other properties that you need to configure, you can configure based on the environment separately. This path should also be configured based on the environment, right? And we will configure it in some time. Now we need to read this properties file. So to read this file, we create an input stream. Here we open the properties file using file input stream and then load all key value pairs into the properties object using properties.load method. In these two lines, two checked exceptions are thrown. One is the file not found exception, which is due to the file input stream, and another is IO exception, which is caused by properties.load. Now, since IO exception is more generic than file not found exception, so we are going to use this in the catch block. Whenever the code throws a checked exception, we have two ways to handle it, either by using a throws keyword with the method or by using try catch. In the framework code, we usually handle the exception using try catch because there is nothing the test can do to recover from it. So we stop the execution early and shows a clear error message. Now we define a public method to access the properties defined in the properties file. This get property method is the only way to access the configuration values. So the tests don't care where the configuration values comes from, whether from files or database. They just ask for a key and get the corresponding value. This properties path is a framework level constant. So instead of hard coding it inside the load properties method, we define it in a separate framework constants class and read the value from there. We will make this class as final, as this class is not meant to be extended and modified in the future. Now this constant class should never be instantiated because it is not meant to represent an object. An object is something that has a state or behavior. A constant class only contains fixed values that belong to the framework as a whole and not to any single instance. That's why we have created the private constructor so that it cannot be instantiated. All values defined in the framework constant class should be public static final because they represent shared constants that must be accessible across the framework and should not change at runtime. We are creating resources folder inside the src test to create the config.properties file. Why it is in src test resources and not in src main resources? Because it is test specific configuration, not application or framework code. The values inside config.properties control how tests run, right? For example, which browser to launch, whether to run in headless mode, what will the wait times. Let us create two properties file, qa.properties and uat.properties to define the environment specific properties. We will add the configuration file path in framework constants in some time. Let's see which values do we need to read from properties file. If we go to the ConfigManager file, this path variable in the load properties method should be configured. Let's refactor this to read the properties file based on the environment. So this is the same code which we used in the load environment method to validate whether the environment provided is correct or not. Once this environment variable is loaded, we can update the properties file path based on the environment. So even if tomorrow there are many more environments added into the framework like staging, prod, dev environment, you need not to change anything, which makes this framework scalable. Let me update the config part with the config folder where all the environment specific files are present. We will populate these properties file in some time. Let us now move on to adding the WebDriver handling code inside the drivers package. Let us add browser factory, driver manager, and WebDriver factory classes in the drivers package. Let us first create browser factory. The responsibility of this class is only one thing: to create and return a correctly configured WebDriver instance. It uses factory design pattern to create the WebDriver instances. Okay, we see that WebDriver is not resolving. So we need to add Selenium Java dependency to the pom.xml so that driver classes are available. So we navigate to the ambient repository and we search for Selenium Java, add this dependency, refresh the pom.xml, and WebDriver is now resolved. The create method takes the browser name and uses a switch case to decide which browser to create. Here we are normalizing the browser name input so that the casing does not matter when we are passing the browser name to the method. So instead of downloading the browser specific drivers, we can use WebDriver Manager to manage the browser drivers. So WebDriver Manager is a Java library that automatically downloads, configures, and maintains the right browser drivers for Selenium, removing all the manual setup that we need to do otherwise. It automates the driver downloads. It matches drivers with the installed browser versions and supports all major browsers. WebDriver Manager not only supports Chrome but various different browsers like Firefox, Edge, Chromium, IE, Opera driver. So it can be used to configure different types of browsers. We will mark browser factory as final to prevent multiple subclasses from creating drivers in a different manner, which can break the consistency of the framework. Next, we create driver manager. The responsibility of this class is to store and provide access to the correct WebDriver instance per thread. So during execution, tests run in separate threads, and each test gets its own WebDriver instance to execute the scenario. Driver Manager, by using ThreadLocal, ensures that each thread receives the correct WebDriver and does not override another test driver. So it makes our parallel execution safe and sound. The Driver Manager is again as private constructor, which means it should not be instantiated. Driver Manager does not represent an object with a state or behavior of its own. So its only job is to store and provide access to WebDriver instances using static methods and a ThreadLocal variable. So we use getDriver method to get the WebDriver instance from ThreadLocal, and to set the WebDriver we use setDriver method. We must also remove the ThreadLocal variable created during the execution at the end of test. This makes sure that the memory stays clean and there are no memory leakages. Let us now implement WebDriver factory. The responsibility of this class is to manage the WebDriver lifecycle. So it does not decide which browser to use, it does not store WebDriver references, it does not contain test logic, It just simply coordinates the creation, initialization, and the cleanup of the WebDriver instances. The init driver method is called once per test execution. This class does not know how drivers are created. It only knows who is responsible for creating the drivers. So it delegates the driver creation to browser factory. After creating the driver, we can apply browser level settings like window maximization and then store the driver in driver manager so each thread can access its own driver safely. So when the test execution starts, for every scenario, the init driver method is called. A separate WebDriver instance is created for that scenario, and that driver is stored in driver manager. So once the test execution is done, that is the scenario executes end to end, then we need to also quit the driver. But first we validate whether the driver is null or not. For example, the scenario fails before the browser or driver is created, right, due to some configuration error or invalid environment. The quit driver will be called from after hook, which will still run. So we need to make sure that the driver value should not be null before quitting the driver, otherwise we will get null pointer exception here. Now this browser value should also be configured. We will be reading it from a properties file. Okay, let's do this then. So we are going to use ConfigManager, which we have already configured, right, to read the properties from properties file. And we are going to get the browser property from the properties file. So we will define one property in QA.properties and avoid this hard coding the browser value as Chrome. So let's do this. Browser equal to Chrome. If you want to run your tests on Firefox tomorrow, then you can just change the value from Chrome to Firefox in the properties file and it will create the proper WebDriver instance by itself. Let us add few more properties in the properties file. Like if you want to run in headless configuration, we do not want to launch our browsers in the headed mode, then we can define this property in the properties file. We will read it using the config manager, and if it is set to true, then the execution will run in the headless mode. This Chrome options defines the settings for the Chrome browser. It tells how the Chrome browser should start. So if the headless mode is enabled, the Chrome will run without opening a visible browser window. If the headless mode is false, we don't add this argument and Chrome opens normally so we can see the execution. And finally, we need to pass this Chrome options to the Chrome driver, which means that Chrome launches with the settings we have just configured. I'm setting headless as false as of now since we need to see the execution when it happens. Let us move on to pages now. Let's create the base page. The base page class is the foundation for all the page classes in the framework. So instead of writing the same Selenium code again and again in every page, we put all the common logic in one place, that is base page. We have marked this as abstract because it is not a real page in the application. It only exists to be extended by real pages like a login page, product page, a home page, any other page that actually exists in the application. So what do we do inside base page? We define things that every page needs, such as WebDriver, wait logic, helper tools like actions, JavaScript executor. Why are they protected? They are marked as protected so that child page classes can use them, but other classes cannot access or misuse them. So protected allows access where it is required and blocks the access where it should not be allowed. The constructor of base page takes a WebDriver as a parameter. This means every page that extends base page must provide a WebDriver. This ensures all pages use the same driver instance that was created for the current test or scenario. Now we can define methods like saveClick, which will wait for the element to be visible and then click on it. For that, we need a WebDriver wait object, which will provide explicit wait, which waits for a specific condition to happen before continuing. In our case, it will wait for the element to be visible and then click on it. So as of now, we are passing this explicit wait duration hard-coded. We will read it from the properties file in some time to make sure it is configurable. Now this method will wait for 10 seconds for the element to be visible and clickable and then click on it. If it is not visible, then it throws the exception, right? Let us add more methods like save type, which will again wait for the visibility of the element and then writes the text into the text box. Then getText method, which will return the text of an element. Let us now add the util class assertion util, whose responsibility is to standardize how assertions are performed across the framework. Instead of directly calling the TestNG assertions, we will use assertion util class to make the assertions. We have made this class final since there is no point in extending it. To use TestNG asserts, we need to add TestNG dependency. Let us go to Maven repository and search for TestNG. So the latest version available as of now is 7.12. So I'm adding this dependency in the pom.xml file. Let's hit that Maven reload button and it will reread the pom.xml and resolve this dependency. This should be resolved now. Okay, why it is not getting resolved? Let me try again. No, we are not getting org.testnc. Mm, what is the issue here? Okay, got it. So in the pom.xml, the scope is set to test only. So it will not get resolved in the src main folder. Let's go to the file and try again. Yes, so it is resolved now. So we are getting this assert from org.testng, which is the required one. Let us add more methods in the assertion util, like assert true, which will validate whether a given condition is true or not. If the condition resolves to false, then it will fail. So these are kind of hard assertions, right? They will halt the execution as soon as the assertion is failed. We can also use soft assert in our framework, which will collect the failures and continues the execution and fail at the end with the full context. Now, if you observe, hard assertions are static because they don't need any state, they will fail immediately. They are simple. But soft assertions, they must remember what was passed, what failed, so they require a state. That is why soft assert is not static and it is initialized per instance. Let me quickly add few soft assert methods like soft assert equals, soft assert true, soft assert false, and in the end we must add soft assert all. So if we don't call assert all for soft assertion, then the failures will be silently ignored and test will pass falsely. Okay, our core framework part is almost complete. Let us make some tweaks to make it more configurable. Like we can read this explicit weight value from the config file, right? So I'm going to define one property explicit weight, and this property will go in the QA.properties or any environment specific properties file which we have created. It requires a long value, right? So we need to parse it in long. We can also define implicit weight as well, which we can use in the driver factory. Now the implicit wait time is set to minimum. As of now, I'm putting it as 0. So we must be very careful while using implicit wait and explicit wait both in the framework, as explicit wait does not override the implicit wait. For example, if we define implicit wait of 10 seconds and explicit wait also of 10 seconds, then the test might take far more than 10 seconds to fail, which makes the execution very slow and unpredictable. Okay, so our core framework is almost ready now. Let us add application specific pages to the framework. Let me create a home page class which will extend the base page. Now, because base page has a constructor that takes a WebDriver, any page that extends it must pass a WebDriver to the parent class. That's why we create a constructor in a child page and call super driver. Let us now move on to the application which we want to automate. So we are going to automate source demo application. Okay, so these are the accepted usernames I will use standard username and this is the password secret sauce, and we hit login. Okay, now so this is the products page. We see many products listed over here and the cart items are increasing as we click add to cart button. Let's start adding locators in the home page. We will use buy locators. Okay, so we need to navigate to the application to see what is the ID of the username. So ID is user-name. Similarly, we will do for password and login button. The buy locators are marked as private, so they cannot be accessed directly outside the page class. Instead, we will expose methods to interact with these locators, right? Which will keep our step definition files clean and readable and free from the low-level Selenium code. Okay, so we will define public methods to interact with these page locators from the step definitions files. So step definition will call directly these methods to interact with the pages. Let's define methods like enter username, enter password, click login button. Now these bilocators we can mark them as final as well, since they are never reassigned or changed during the scenario execution. So it is better to mark them as final. Let's write our flow in the feature file. Let us create feature file in the resources. We will create a directory features and we will create our first feature file login.feature. So I'm giving the feature name as validate login functionality. Let us write a first scenario, validate positive login scenario. This is only for demonstration purpose, just to verify that code is working correctly and everything is behaving as expected. So let me quickly write this scenario that user is on the login page, user enters username. We will pass the username from the feature file itself. We will read this password from the configuration for now, but in a real project, it should be stored in a secure place like environment variables and not hard coded inside a properties file. Okay, so now in the src test Java step defs package, let us now create the step definitions for this feature file. We will name it as login step defs. So we need Cucumber given when then to write the step definitions. For that, we will go to the Maven repository and take the Cucumber dependency and put it in the form.xml file. And the dependency should get resolved now. Yes, it is resolved. So let us write the step from the feature file. User is on the login page. Now, these step definition acts as the bridge between the feature file and the page layer. So each method here represents a behavioral step. Now we create the home page using the WebDriver from the driver manager, which ensures that the step definitions always use the correct driver for the current scenario. Now, as I write the code, I want you to observe carefully and try to identify the mistakes and bad practices on your own before we fix them. So we did not use any access modifier with the home page constructor, and it should be public to use it outside the package. So you see every little detail matters. Now to navigate to the home page, let us add a method in the home page class. Also, observe all the mistakes that we are going to introduce in the framework from now on. We will rectify those, but we should be aware like what all are bad practices. Okay, let's use standard user to log in into the application. Let me quickly write this step. So this username we are getting from feature file and we have just called the method enter username. Now we enter the password. The password we will read from the config file. Ideally, I should have waited for you to guess this, that this is a wrong practice. Okay, so as of now, let me add it to the QA.properties file. But in real projects, sensitive data like passwords should never be stored in plain text, even in configuration files. They should be either stored in environment variables or as encrypted secrets or some other vault services, but never in plain strings. Okay, after clicking login button, then user should be able to navigate to the home page. So this will be the assertion step. So given is the initial state of the system, such as user navigates to a specific page or user logs in. When is the action? So user performs some action, for example, clicking a button or submitting a form. Then is the outcome, where we actually validate the result of that action, if the expected behavior is correct or not. So we will add this assertion in some time. Let me take a note of it here. Now our feature file and step definition file is ready, but they don't execute by themselves. So we need a test runner file, which we will create in the runners package. We need Cucumber TestNG dependency to integrate Cucumber with TestNG. Using this dependency, each Cucumber scenario is treated as a TestNG test method. So we can use TestNG features like parallel execution, data providers, and testng.xml file. Now in test runner, we will use @cucumber options annotation, which is used to configure the Cucumber tests. Now in it, we will configure where our feature files are located, where the step definition and hooks files are, which scenarios we want to run, what kind of reports we want to generate. So features option points to the feature files. Glue tells Cucumber where to find the step definitions and hooks. We can also define tags which control which scenarios we want to run. If there are any missing step definition implementations, we can set dry run to true, and Cucumber will generate the corresponding step definition snippets for us without executing the scenarios. Now, plugins control how test execution results are reported. They allow Cucumber to generate readable output such as console logs, HTML report, JSON files. Now, our TestNG runner class extends the abstract TestNG Cucumber tests. So, what does this class do? So it enables the TestNG features like parallelism and handles scenario execution internally. Now we override scenarios method to enable TestNG to control scenario execution. We have passed parallel equal to true in the data provider. This is where the parallel execution actually happens. So each Cucumber scenario is treated as a TestNG test method whose parallel execution is enabled using that parallel equal to true property. Let us now write hooks class. So this class decides when browsers start, when they stop, and what happens when a test fails. So things like what happens before a scenario, what happens after a scenario, what do we do on failure. So all these things are answered by hooks. Now we have created this method at before scenario with @before cucumber hook. So it defines the code that runs before each scenario, where it simply initializes the driver by calling the WebDriver factory.init driver. Now in after cucumber hook, we can define what do we do on failure. So once the scenario execution is completed, we can check if the scenario has failed. Let us take a screenshot and attach it to the cucumber report. For taking these screenshots, we will write a screenshot utility. But before that, we should quit the driver as well once the scenario execution is completed. So we can do that by calling WebDriver factory.quit driver, which we have already written. Let us now create a screenshot util class. We will mark this class as final as this is a pure utility class and it is not meant to be extended. Now the method we are defining is a static method, right? So that it can be called without creating an object. We will capture the screenshot in byte format and return the bytes. Returning the screenshot as a byte array is important because Cucumber's scenario.attach API expects data in this format. which allows the screenshot to be directly embedded into the Cucumber report, especially on the test failure. So we are creating this timestamp variable which we will append to the screenshot name. Why? Because if the same scenario fails multiple times, the screenshots do not overwrite each other. So this is for the future purpose. Now this regular expression in the replace all is very important because scenario names can contain spaces or special characters that are not safe for file name. Let us now add the proper values in the attach method. We'll use now screenshot util to capture the screenshot as bytes. We will define the media type as image/png, and we already provided the screenshot name. As of now, we are not able to navigate from a feature files to step definition. This is because we need to install Cucumber for Java plugin, which enables the navigation and gives warning for the undefined or unused steps. Okay, so now we are able to navigate from our feature files to step definitions and back from step definition files to feature files. Let us now try to execute one scenario. But first we need to add the hooks path in the glue as well, as I have mentioned before. Plus, let us now give a tag to this scenario at the rate login test. As I've previously mentioned that we can define tags as well to run the scenario. So let's give tags as at the rate login test and try to run this. Let's right click and run the test runner. Okay, the execution has started. It has opened the it has opened the window, but it closed very quickly. The execution was very fast, so we were not able to see anything over the screen. Okay, let me add some weight when we are navigating to this page. But before that, let us see the report which is generated from this execution, like if our reporting is working fine or not. Okay, let me right click and open it in browser. Okay, this is the report which is generated. Now, because the scenario has passed, there is no screenshot which is attached to the report. Let me write a step where I intentionally fail this scenario. So you see now that because of that plugin, we are getting this squiggly line before below this step that this is not created, and we can directly create the step definition from the feature file by clicking on that create step definition. Now I will intentionally fail this step by making the assertion that assert.fail, right? Let me again run this scenario and it should fail this time. So okay, so it has opened the window, source demo, okay. Now this has failed. Let us open the report and see if it attaches the screenshot to the report. I right click and open in browser. Fine. Okay, so we have written the code to take the screenshot in the after hooks. So if you see that in the after, there is one screenshot attached at the step where the scenario has failed. Okay, those screenshots are getting attached. Let us now test something else. Let us now check whether our parallel execution is working fine or not. So let us create one more scenario in this feature file. I will not write any functionality as such. I will just reuse the same steps. So one scenario should pass and one scenario should fail. Let's make it like that. Okay. Okay, so let us now execute the scenarios. So no scenario is executed. But why? Because Cucumber tried to find scenarios with the tag at the rate login test. But since no scenarios had that tag, nothing was executed. Let me remove this tag and execute again. So Okay, now two scenarios are running in parallel. We saw that one scenario has passed and one scenario has failed, just like we expected. So this is running fine, but ideally this parallel test execution should be controlled with in the testng.xml file. Since our test execution engine is TestNG. So in TestNG.xml file, we can provide data provider thread count, which can control the number of scenarios that can run in parallel. So let's add testng.xml file in the framework. We will add it in the src test resources. When we run from test runner, Cucumber scenarios are executed by TestNG using a data provider. Setting parallel equal to true in the test runner allows scenarios to run in parallel, but the actual number of parallel scenarios is controlled by TestNG's thread configuration. Now we have two types of TestNG configuration parameters, thread count and data provider thread count. To run Cucumber scenarios in parallel, we need only data provider thread count. So thread count matters when we want to run the TestNG tests. If we do not provide any of these value like thread count and data provider thread count, the data provider thread count value defaults to 10. So 10 scenarios will run in parallel if we do not provide this. So we have set this to 2 as of now, and the thread count defaults to 5. So if we run from testng to XML file, then we will see only 5 scenarios executing in parallel in case of TestNG only framework, but this is our BDD Cucumber framework. Now if you right click, we should get an option to run testng.xml file. Okay, but we are not getting it. We have its dependency over here. So this testng.xml file is not properly recognized because Maven is not configured yet to acknowledge it. So Maven acts as the project manager. If it does not know about the test suite file, the IDE integration may not work correctly either. So let us add the Maven Surefire plugin configuration in pom.xml file and explicitly define the testng.xml file path. Let me hit Maven reload. Now if we click on testng.xml file, we see that now it is able to detect this. Okay, so let us try to run these scenarios sequentially by giving the thread count as 1. So it only depends on data provider thread count as we already discussed. So first scenario done, second executed, which is fine. Let us now try to execute from the test runner file and see the behavior. Okay, now even though the data provider thread count value is 1, when we are running from test runner, both the scenarios are executing simultaneously. But why so? When we right click on the test runner class, right, the ID creates its own TestNG configuration and does not read our testng.xml file. So as we know that default setting for data provider thread count is 10, so it uses that testng default value and not the one which we have written in our configuration file. But when we right click on our testng.xml file, it uses the explicit configuration which we have set, like data provider thread count is equal to 1, and runs sequentially as expected. Okay, now let us write this tab to assert that we navigate properly to the next page. Let's go to the application first. Let's see which element we can identify. We will keep it simple for now, right? We will just navigate and assert any one of the element present on the next screen. So this is the products screen. Okay, we have all the products listed over here. Let us inspect it. Okay, let me find it using text only. That's fine. Okay, so now let's go to the pages. Let's go to our home page. Actually, we have all the login page locators over here. So let me refactor it with the login page name, right? So ideally it should be login. Now let us add one more page into our pages package, product page. So where all the products are listed over there. Okay, as we add product page to the framework, you can see that the base framework is already in place. When we when this page extend base page, we are forced to create a parameters constructor and pass the WebDriver. So the WebDriver is initialized automatically. Everything starts falling into place because all the internal wiring has already been handled by the framework. So this is an example of good framework, right? So nothing is left behind. We are doing everything from the very basic. Let us add the product label locator which we have found from the page. Now pay close attention to what I'm doing. Think of this as a small test. I'm going to intentionally make a few mistakes and I want you to spot them. Once I'm done writing the code, I will point out and explain those mistakes. Okay, so we need a product label to make the assertion on. So we have this step mentioned over here. User should navigate to home page. Let me refactor it to products page. Okay, now this product specific step definition should go inside the corresponding step definition file. So let me create one more step definition file, products step def. Okay, so let's add that step definition in the product step def. And now we need to create the product page object, right? Now we need to make this assertion that this product label should be displayed. So let me go to the assertion util and add one assertion method here. Public static void is element displayed. Okay, we will pass in web element. Okay, now let us make the assertion assert true element dot is displayed, comma, let us give the message web element is not displayed. Let's use this method in the step definition. Assert element displayed, it should come from assertion util dot. So we have by element, not the web element over here, right? So we need to find the element using driver.find element. Let's try to execute the scenarios now from the test runner file. Okay, both the scenarios have executed so fast. Let me add thread.sleep just to see how the execution is going on, that our page is loading or not, right? Using thread.sleep is a bad practice because it hard stops the test execution instead of waiting for a real application condition, right? So we should never use thread.sleep. Now we are returning this by locator from our page file. This is a very wrong design pattern. So the beginners make this mistake very often, that they try to return by locators from here. Now in the step definition, you see that we are using driver code because of this. So this is also a wrong practice. Here using driver manager.getDriver, we are creating driver in the whole step def file. That is why we were able to use it, the step definitions. So ideally the driver should not be available for steps to use directly, right? So we will pass this as an argument directly and we will not create a driver variable over here. So driver from step definition file is gone, which is good. Now we will write this method again. somewhere else. But let us first remove this by element which we are returning from the page class. So we will create one method that validate product label is displayed, and we should call this method from our step definition file. Now this element displayed method should not be present in this assertion util file. So we will write this in the base page so that it is readily available for all the pages. So we will define this method here, protected boolean is element displayed, which will take the by locator. Now we will use explicit wait and wait for the visibility of element to be located. So now we can use this method directly inside the product page, and we can utilize the assertion util method assert true to validate if this element is displayed or not. So this whole code is removed from the product step def. Now it is much more cleaner. We are just directly calling the method from the step definition, and there is no driver code, only the behavior of the product page. Okay, so let me now run this scenario at login test underscore pass, and we'll check if our changes are working fine or not. Okay, yeah, it is working fine. Now I will do rest of the refactoring, removing drivers, removing thread.sleep, right. Making it final. So we are done with the Selenium framework creation. So if you found this video helpful and now feel confident about creating a Selenium framework from scratch, don't forget to like the video and subscribe to the channel for more in-depth automation content. Thank you.